students, today we shall learn lesson 4 of science, current, electricity and magnetism. The topics we are going to cover today are current electricity, electrostatic potential, potential difference, electrical circuit and electric cell, where we will learn about dry cell. Here we can see the structure of an atom. What is an atom? All matter in the universe is made up of small particles known as atoms. Atoms are further composed of particles called electrons, protons and neutrons. The protons are positively charged, electrons are negatively charged and neutrons are neutral. We know that an atom has same number of positively charged protons and negatively charged electrons, and hence an object doesn't show any charge though its atom contains charged particles. Therefore, we can say that plenty of electrical charge is filled in the objects around us. What will happen if a glass rod is rubbed on a silk cloth? The silk cloth will develop negative charge and the glass rod becomes positively charged. So how does object get charges? An electric charge is created when electrons are transferred to or removed from an object. Electric charges are of two types, that is, static charges and the moving charges. Static charges are stationary charges or non-moving charges. Moving charges get transferred from one object to the other. These are negatively charged. Moving negatively charged particles are the electrons. We know that water flows from a higher level to a lower level, and when we apply a force to a stationary object, we can set it into motion. In the same way, we can get current electricity when the electrons in an electrical conductor are made to flow. You must have seen lightning occurring during rainy season. Lightning is the electric discharge traveling from the clouds at higher potential to the earth's surface, which is at zero potential. A large current flows when lightning takes place from a cloud to the ground, while sensation is felt by us due to a microscopically small current flowing to the brain. You are aware of the current flowing through wires, electric bulbs and equipments in the house. In the electric cells of a radio or in a car battery, a current is produced by the flow of both positively and negatively charged particles. Water or a liquid flows from a higher level to a lower level. Heat always flows from a body at higher temperature to a body at lower temperature. Similarly, there is a tendency of a positive charge to flow from a point of higher electric level to a point of lower electric level. This electric level deciding the direction of flow of electric charges is called electrostatic potential. Similar to the height of a waterfall, the temperature difference of hot and cold bodies, there is also a difference between the potential of 2 points, which is called the potential difference. Now you can try this. Take connecting copper wires and connect the circuit as shown in the figure 4.1a. No current is seen to flow in the bulb. Now connect the same circuit, a 1.5 volt dry cell available in the market as shown in the figure 4.1b. Now it will be realized from glowing of the bulb that a current is flowing in the circuit. In the figure 4.1a, there is no current as there is no potential difference in the absence of any cell. Current starts flowing in the circuit as soon as the potential difference is applied. Electrons in the wire flow due to the potential difference between the two ends of the dry cell. These flow from a negative terminal of the cell to the positive terminal of the cell. Conventional current flows in the opposite direction and is shown in the figure by the sign of an arrow. The unit of potential difference in the SI system is volt. We have seen that electric current is produced due to the flow of charged particles. Electrical charge flowing through a wire in 1 second can be called unit current. The SI unit of current is coulomb per second, or it can also be called as ampere. Therefore, 1 ampere equals to 1 coulomb upon 1 second. Electric current is a scalar quantity. A source is required to produce a uniform flow of charge in a circuit. Such a general device is an electric cell. So what is an electrical cell? An electrical cell is a device used to generate electricity or to make chemical reactions by applying electricity. Various types of electric cells are available today. These are used in a range of machines from wristwatches to submarines. Out of these, you must be aware of solar cells. The main function of various electric cells is to maintain a constant potential difference between its two terminals. The electric cells work on the electric charge to maintain a constant potential difference. Let us learn about the electric cells that are currently in use, like the dry cell, which we use in the wall clock, or the lead acid cell that we use in car, and the nickel cadmium cell. You all must have seen a dry cell. The dry cells are used in our radio sets, wall clocks and torches. These are available in 3 to 4 sizes. Now let us learn the construction of a dry cell. You can try this at home. You can take a used dry cell and remove its outer coating. Inside you will find a whitish metal layer. This is the zinc metal layer, and this is the negative terminal of the cell. Now carefully break open this layer. There is another layer inside. An electrolyte is filled between these two layers. The electrolyte contains negatively charged and positively charged ions. These are the carriers of electricity. The electrolyte is a wet pulp of zinc chloride and ammonium chloride. There is a graphite rod at the center of the cell. You can see in the diagram. This is the positive terminal of the cell. A paste of manganese dioxide is filled outside the rod. Because of the chemical reactions of all these chemicals, electrical charge is produced on the two terminals, that is the graphite rod and the zinc layer, and an electric current flows in the circuit. Due to the wet pulp used in this cell, the chemical reaction proceeds very slowly. Hence, a large electric current cannot be obtained from this. Compared to the electric cells using liquids, the shelf life of dry cells is longer. Dry cells are very convenient to use, as these can be held in any direction with respect to the ground and can be used in mobile instruments.